I have always been fascinated by magnets. I can play with them for hours together. The most curious question I always had about this is, how does the magnetic force transmit over a distance? You don't need to touch it to push it. I think that's what fascinates everyone about magnets, right? So how does the magnetic force work? How does it travel over a distance? Does this magnet somehow know that there is another magnet out over there? How does it know? Is it aware of its surrounding? What's going on? Well, here's how we like to think about it today. We don't think that the magnets directly push and pull on each other. Instead, we like to say that this magnet, for example, creates some kind of an influence around itself, making its presence felt far away. And it's because of that influence, the second magnet gets affected. So let me give an example. The other day when I entered the house, I immediately got a strong smell of jasmine. Now, I don't like jasmine a lot, but my wife loves to wear it. So because of that fragrance, I immediately could feel the presence of my wife somewhere in the house from a faraway distance. So you see what the flowers had done? The flower had created some kind of a fragrance all around the house, making its presence felt. And the moment I walked in, my nose came in contact with that fragrance, and I automatically experienced a smell. In a similar manner, we could think that this magnet, for example, is creating some kind of a magnetic fragrance all around it. And when the second magnet comes in contact with that fragrance, it automatically doesn't experience a smell, but it automatically experiences a force. So this magnetic fragrance, we give a technical name for it. We call it the magnetic field. So this magnet is generating a magnetic field around itself. And when the second magnet comes in contact with the field, it's getting pushed by that field. And similarly, even this magnet is generating its own magnetic field, which I have not shown over here. And that field is the one that's pushing and pulling on this magnet. So it's the fields that push and pull on other magnets. However, there is a big difference between magnetic fields and the fragrance created by flowers. You see, what we call as fragrance is basically some molecules which are spread out by the flower, which mix into the air and enters into my nostrils and creates a smell. But over here, the magnets are not spreading out any particles into the air. There are no particles moving anywhere. But still, their magnetic field exists. So that makes it a little bit more interesting and a little bit deep. But another question we could ask over here is, if there are no real particles that we can detect, then how do we know that this magnetic field is real? That it really is present, it exists? How do we know that? Well, here's how. Suppose I keep this magnet close to this magnet. Then we know that right now, this magnet is pushing this magnet away from it. But what do you think would happen if I were to instantly make this magnet disappear? You might expect the force on the magnet will also disappear, right? But careful studies, careful experiments show us that the force does not immediately disappear. It shows us that for a very, very small fraction of a second, that force still exists. The force does not instantly disappear, but it lasts for a very small amount of time. How do you explain this? Well, again, if we come back to our example, let's say I go to my wife and then I take those jasmine flowers and throw it outside the window. What do you think is going to happen? Well, my wife is going to be pretty mad at me. But besides that, do you think the smell in the room, the fragrance in the room immediately vanishes? No, it doesn't, right? It would still be present for some time, even though those flowers are gone. Its presence can still be felt for some time. You may have experienced this. Similarly, over here, this magnet is producing its own magnetic field around it. Now, when we make this magnet disappear, its field doesn't instantly disappear. Its fields last for a very, very small amount of time. Now that time is extremely small, maybe fractions of a nanosecond, something that we may not be able to detect in our experiments, but it doesn't matter. It does exist for a very small time, and it's during that time this magnet can still feel the presence of the other magnet. So the very fact that the force is still present for a very short time, but it doesn't matter. However short it may be, it doesn't matter. It existed for a short time, even when this magnet was removed, convinces us that magnetic fields are very real, that they're there. And the field concept is so incredible that we have now applied them even for other forces over a distance. For example, how do these charges pull and push each other over a distance? Well, we can say the charges produce an influence around themselves, making their presence felt. This influence is called the electric field. It's called electric field because it only affects electric charges. And similarly, even the force of gravity, say between Earth and the Moon, acts over a distance. How does it work? Well, we say both the Earth and the Moon create a gravitational field, and it's the gravitational field that pushes other objects which have masses. Gravitational fields affect masses, electric fields affect electric charges, and magnetic fields affect magnetic materials or magnets. So to summarize, how do magnets push and pull each other over a distance? Well, they don't directly. A magnet will create a magnetic field around it, making its presence felt far away. And when any other magnet comes in contact with that field, it automatically experiences a force.